Hi everybody, Stu, AG6AG. Today we are going to talk about a broadband butterfly terminated dipole design that a friend of mine sent me an email, God, must be 2-3 years now ago. KM6GUE sent it out to me, and he was planning on putting it up, and he actually decided not to. But he was going to use it for the stealth quality, and the image that he showed me was basically a balun on one side, a resistor assembly on the other, and two wires that went around the baseboard of the roof of the house. In other words, the fascia boards all the way around. And it claimed in the website that it could, depending on the length and some of the other things, but with a little bit of work, you probably could get 6 through 160, at least close enough that you could tune it. And all right, I wanted to see that. So I was going to build one and set it up at my house just to play with. Time went on and things happened, and I wasn't able to do that. But a new problem came up that required me to come up with a stealth antenna design. So this video covers the installation and how this all worked out for me using this broadband butterfly terminated dipole design. But first, let's get all the disclosures out of the way, shall we? This project began with the idea that I would make a video about stealth antennas and evaluate each antenna against a not-so-stealth antenna to come up with a comparison that would assist other amateurs in making a choice as to the validity of these solutions.
Then I realized that an evaluation in most cases wouldn't matter in the first place, since there was no ability to make a real choice based on performance. I mean, after all, these were stealth antennas and are surely a compromise in the first place, and not going to have the same performance as a full-fledged antenna. I instead have elected to show solutions that are commonly accepted as good and publicly accepted compromises of antenna design that would allow operators to get on the air and hone their skills as HF operators. The testing methods used in this video are extremely basic and do not fully test the antenna's ability to make QSOs or operate at any given distance near or far. Play with this stuff at your own risk.
Well, okay, all kidding aside, what I'm really trying to say here is please, make sure that you test out the things that you're doing. You make sure that the antenna's SWR is below a range that your tuner will handle. Please, when you deal with these stealth or interestingly designed antennas, especially broadband antennas, you really need to be conscious of what the SWR is coming back. So my initial problem, of course, was that I needed to get a HF antenna at my office. Now, my landlord at my office building does not allow me to go up on the roof and put up antennas. Doesn't allow anybody to do it. I have a VHF UHF antenna that's up in the ceiling, and it works fine. But every time I need to test out an HF rig or something like that, I end up having to run coax out to the front, put up a temporary antenna in the parking lot, or move everything out to the parking. It becomes a giant pain in the you-know-where. So, and as I begin to get more and more involved with amateur radio, I found out that I really needed a workbench with some test equipment and stuff like that. So here's my test bench, and it actually is located in my office up in that far corner where the hand is. Now, I have to tell you that I looked at a lot of different solutions for antennas, but I kept coming back to this antenna design that my buddy had sent me an email, as I had mentioned earlier. And I have to tell you that that's where I went and looked again at hflink.com. That's where that antenna design existed. And I had even researched it enough that I had built a 16-to-1 balun, and I'd set up a resistor pack that I could use that would handle the wattage in order to set up this antenna, and I had it just waiting there. but just did not have the time or actually the gumption to get up on the roof at the house and do it. Now I had a reason. So let's take a look at hflink.com. I really like this website. This website actually was designed and written for ALE on the air. ALE is basically automatic link establishment for high frequency communications, right? And that requires broadband antennas. It requires dedicated antennas. So it's awfully hard for you to do this on multiple frequencies if you don't have one antenna that does all the bands. And that was kind of their antenna idea here. And this is where they talk about broadbands, auto tuners, things like that. But they have a whole section here on broadband butterfly terminated antennas. And this is the basic design. Okay, I have a friend that has one of these, although it's stretched out longer as a dipole. They work really well. They really do. And I can scroll down. They talk about different measurements for the ground, basically termination, dB loss or gain, things like that based on length. Other things, feed point locations. I mean, they go into great detail as well as the radiation patterns. And again, they have several different layouts for this antenna if you were going to do it in a non-stealth manner. They also discuss several things about doing it in a stealth manner. One of the things that they do is this, and I fell in love with this. This is the graphic that my buddy sent me. And basically, I was going to do this. And I read through the article here, and it really doesn't take any kind of special knowledge to get this set up, other than you got to figure out, try to make the both sides of the antenna the same length within about a meter, or within about 2 meters, about 6 feet. Okay, and you have to have 1,000-watt or 1,000 ohm resistor that can handle the wattage you're going to put out of your radio. So if you're using 100 watts, you need something that'll handle 100 watts, right? And it talks about the higher you get it, the better off you are. The longer the wires, the better off you are for certain bands, the shorter the wires. And it goes into detail. I encourage you to go here and go to this site and take a look at this before you go to set this up if you plan to do it. All right. This also, by the way, shows a house that has all sorts of turns and angles, and you know what? It doesn't matter. According to this, it'll work any cut or turn or whatever, or under something or over something. It's not going to hurt what you're doing. You can even stick this out in the outside kind of as a stealth antenna, running just wires to your backyard, right? So now, this was the design that I used to make the balun. I'm not going to go into the balun because I have another video that shows that, and I'll make sure that there's a link to this website as well as a link to that other video in the description of the video. And I'll also put the link up above me here for the video, because I go into testing this balun, how it was built, and the whole discussion there. And I compare it against a commercial balun, a commercial 16-to-1 balun that I purchased, and discuss cost-benefit analysis for that, right? Anyway, so in order to set this up, well, hey, guess what? I just went around the perimeter of my office, and as you can see here, I've got up above me, that yellow thing up there is where my 16-to-1 balun is. And over there in the water closet, you see where the resistor is. And I basically just ran it all the way in the square area of my office. I've got, I'm going to say between, I'm a little short. I've probably got about 80 or 90 feet on each element side, and it's probably more ideal, a little over 100. read the documentation, like I said, to get an idea what you need to do. But we'll go over the results once we got this up. And oh my God, by the way, I got to thank my buddy Mike for coming out and helping me get this ran all the way around the office on the inside. Now, I'll also tell you that we were going over electric cables. We were doing... This thing is probably the worst installation that I've ever done as far as doing it by the book. However, nothing is going to have any fire danger or anything like that, but there's lots of opportunities for us to pick noise and other things up with this antenna based on how we ran it. But again, these were our only choices, so that's what we did, right? There's a picture of that 16-to-1 balun, and it's installed over in the corner over by where my test bench is, right? Just mounted on the wall, and you see the wires, they just go up there and around, nothing big. It wasn't difficult in the fact we had to get on ladders and kind of climb on stuff. My office is hard to get around in by the walls because we got a lot of stuff stored there too. Now, make sure... If you want to learn about this balun, there is the link. And again, I'll stick it back up here again, and I'll also put it at the end of the video to see this. And this is where I do testing on the baluns and just go through a total analysis of that. So you might be interested in that. If not, if you're just going to buy a commercial one and you don't care, you don't have to go watch it. But there's a lot of great information in there, all right? And here, of course, is a picture of the resistor. Now, these are 4 resistors, basically, and the 4 resistors that are in here are film resistors, right? Because you don't want to use wire-wound resistors because they create what? Inductance, right? And you'll have all sorts of problems getting a match on the antenna, so you need to be careful with the resistors that you pick. Now, originally, this was going to go at my house, so this is capable of handling about 400 watts. I have 4 100-watt 1,000-ohm resistors, and I basically put 2 in parallel and another 2 in parallel, and then put those in series to get my 1,000 watts, okay? Anyway, or my, 1,000 ohms for my 400 watts. Always get that messed up for some reason when I'm talking. Anyway, so let's take a look after we got this up at the antenna's performance, okay? Now, this is an SWR chart for 6 meters. 6 meters actually came out pretty good. I was surprised. 1.28 to 1 at the very lowest point over there. And then as we come up at the very highest point, it's only 2.5 to 1. This is totally tunable. We don't need to worry about getting it tuned at all. This will work with a tuner. And if I'm down at the low end, if I'm down at the end of the band that is CW and even some of the sideband area, I probably could get away without a tuner, okay? Now, again, your mileage may vary. Make sure you check your stuff after you get it up. Let's take a look at 10 meters along the same lines, right? The low side of this, 1.26 to 1. That's down at the low end of 10 meters. Again, the CW digital and some of the sideband there. The high, 2.87 all the way up at the top corner of this. This is totally tunable, okay? With an external tuner, you can make this happen. Now, let's take a look up, wrong way. Let's take a look at 12 meters. You know, this is 12 meters totally flat at 2.2. I can't complain about that. That, again, is a totally tunable SWR, right? How about 15 meters? 2.4 to 2.9. We're still in the right range. And then when we start getting into the phone side on 15 meters, that's where the low side is. So this is doable. 17 meters. 2.4, 2.7, 2.5. Totally tunable. I would not run anything over about 1.6, 1.7 without a tuner, okay, just to put that in perspective. But with a tuner, totally doable with this. This might even be in the range of a tuner built into the radio, but if you've heard me talk before, you know that I don't think that you should use a tuner in the radio. You should always use an external tuner that has some horsepower to it to be able to protect your rig. Okay, that's just me. Take a look at 20. I run this without a tuner, 1.5 to 1.75. I'd be okay with that. I still run a tuner, but if something was wrong, I could run it without a tuner. Something was wrong with my tuner. 30, well, under 4, I can still tune it with a reasonably good external tuner. It is all digital. I'm going to experiment to see how well that actually works, but that's a little high to me. I might be able to get that down with some adjustments, but I'm not changing anything on the antenna because after all, it is in there for my test bench, right? I'm not going to be operating full time off it, but I wanted to make sure that I knew all this stuff before I hooked somebody else's radio up to it to test it. 40, well, this is a disappointment to me. Now, I imagine if I went with maybe longer wires, I would have done better with this, maybe farther off the ground. But 5 to 1, that's given up a lot. And you know what? If that's all I got, and I'll tell you, my first antenna at the house was more than 5 to 1, and I used to tune it. It worked fine, but you really need a good tuner to take care of this. I wouldn't transmit on this at all without a tuner, okay? Let's go ahead. 60 meters. You know, that's not bad. That's tunable, right? It's under 3.5 for the most part. I'd run with that with an external tuner. 80 meters. This was the big shock to me that the phone portion of 80 meters is the low portion of 80 meters, and even at 2.25, I can tune 2.25 on 80 fairly easily. And then, of course, well, 160, the wire's too short, period. I know that. I needed more area that I just didn't have. But you know what? I can still get my tuner to tune that, right? Now, what does that really mean, though? And let's talk a little bit about that. Now, a compromised antenna means that you're not really going to get any gain out of that antenna, okay? Matter of fact, you might have negative gain. In other words, the antenna might chew up some of that power. It may not have the best pattern. And, you know, it may be as much as 6, maybe 7, 8, 9 dB under what we all kind of use as a mental standard, which is a dipole antenna cut to full length. But if this is all you can get in the air, that's okay. You know, I tested this antenna on 20 meters, talked to a guy down the road from me. I plan on doing some digital testing. I tuned in on the FT8 bands, on a radio. Unfortunately, I wasn't able to transmit because it was a radio I was testing for somebody and it not set up for digital. But hey, S8, S9 signals coming in on this antenna. That's pretty good. I mean, think about it. This thing is inside my office, right, which is a reinforced concrete building all the way around it. All of the metal in the walls, all the studs are metal studs because they're false walls. I'm going around a false ceiling, right, that has the little metal rails right next to it. Okay, and there are sections in there where I had to come up over the top and actually go over the top of electrical conduit that's running 120 volts AC, which obviously is going to interfere. So, hey, I have to say that I'm feeling pretty good about this antenna. Anyway, I may do a couple more videos on this, but I'm hoping that I've kind of shown everything in this that you want to know. And something important that an old ham told me one time. He said, Stu, the only bad antenna is the one you haven't put in the air. With that, I'm Stu, AG6AG, and I hope to hear you out there on the air. 73, everybody.